is affected, which is to me is a little bit strange intuitively. You would think that it would change in distance, but when you really think about it, it makes sense. It's still the same shape. So this last part is always about contextual meaning or definitions or things like that. They always ask a question like this on the exam. Talk about the shape, center, and spread of all three. So what do you know about all three shapes?
They're approximately normal.
Okay, they're approximately normal. So first of all three shapes are the same because none of them change. Remember, the shape doesn't change. And approximately normal, because they told us that. Second, the center. I guess I would say something like, if we're comparing the differences, that is, and I go back and I look up at T, the mean of T is 50 times the mean of X, and the mean of C is 50 times plus 100 that of X. And then the spread in both T and C, the standard deviation is 50 times, bless you, that of X. Because remember, the spread remains the same when it's affected with the 50, whether you add the 100 or not. So it will, both of them, the new ones, will be 50 times that of the original. Here. So in this one, we're going to talk about combining these two random variables. Like, what if you not just have X, but you actually have an X and a Y, and you want to put them together? First of all, when you have the means, down below you will see when you have two means and you want to add them up together. So you have a new variable called T, and you want to put the random variable X and the random variable Y together. The means, just add them up. Super difficult. If you are subtracting the means with a new variable, subtract the means. Are you okay? All right. In the variances, if you're adding two variables, the variances, you add them. And if you're subtracting those variances, they say that you subtracted, but really in the end, it still comes out to be adding, because you're swearing. So just remember with variance, you're adding. Something kind of important down at the bottom here, an exam tip. You can never add standard deviations. It's a very common mistake on the AP exam, and I've told you today a few times. In order to find standard deviation, you have to actually do the variance. So the exam tip is, in order to find the standard deviation for a combination, you'll add the variances together to find the new variance, and then you'll find the standard deviation. So put a star by this tip. This is kind of important. A lot of people forget about this and get the variance right, but the standard deviation wrong. So don't forget, do the variance first. So let's try some examples with this. First of all, in example 1, B is going to be the amount spent on books in that fall semester that we were talking about at El Dorado. The mean for the books is $153 with a standard deviation of $32. Don't forget, C is the overall cost for the tuition, and that has a mean of $832.50 and a standard deviation of 103. So in part A, we're going to find the mean and the standard deviation of the cost of tuition fees and books. Or in other words, the C that we've already found and the new B for this randomly selected student. So if I'm looking for, in this case, the mu of this new thing, the C plus B that is, it will be the mu of the C plus the mu of the B, or in other words, our original cost, which was $832.50 plus the $153, which was the new information, for a grand total of $985.50. Now, a special note here, the standard deviation of the cost in the books can't be done because, anybody know why?
We find the variance of each one, and you add the variance together and reduce the variance.
Definitely on the right track,
Yeah.
but something kind of subtle. The two variables are not independent. Or in other words, exactly what you were saying, because in order to know what's going on for each one, they'd have to give us the data for each one, because they depend on each other. We can't do the standard deviation. We don't know.
So, does it tell us that?
Good questions.
Just let you know.
Okay, part B. In part B, the community college also has a downtown campus that specializes in a few fields. So Y is going to be the number of units taken by a full-time student there randomly at the downtown campus. Their mean is 15 and the standard deviation is 2.3. They pay $55 a unit, and we're going to let you equal the cost of tuition. Find the mean and the standard deviation. You try.
We don't have
Don't write it down. Don't write it down. I don't really care. Okay, so in this case, the mu of my new defined variable, which is u, that's funny, would be the $55 per credit times whatever the original y was, so mu y, or in other words, 55 times 15, which is a total of $825. So this is kind of a redundant question. It's a different thing, but it's, I think, in preparation for what's going to happen next. So you already know how to do this. We already did one like this on the previous slide or 2 slides ago. No big deal. And then the standard deviation for this u is going to be the same thing. It's 55 times the standard deviation of the y, or in other words, that 55 times, what did they tell us it was?
2.3.
2.3, thank you. 2.3, or in other words, 126.50. So if you don't have this on your packet, if you would just write down the numbers that you don't have, which will help remind you where these numbers came from. If you do have the numbers, I think you're good to go. This is nothing new for you guys. We already did one of these. I think the reason that they gave us this part is so that we can do part C. I want you to try part C. Holy moly. Interpret. Binomial. Geometric. Yeah. Okay, so looks like we've been recording this whole time. Yeah.